In this video, we will be looking at section 4.5, finding an equation from its graph. So that's exactly what it says. We will be given the graph, coming up with the equation, where in the previous sections, especially we're not going to deal with any tangent, cotangent, secant, or cosecant. These will all be sine and cosine graphs. But in the first couple sections, you were given the equation and you would come up with the graph for that equation. Reverse that. This time they're going to give you the graph and you've got to write the equation. So a couple things to review before we do this. Remember in your basic outline of your equation, whether it's a sine or cosine, sine graph, so remember the A is your amplitude. B determines the period, so to find the period it's 2 pi divided by B. C determines or is what causes a phase shift, so negative C divided by B, remember, is how you find your shift, horizontal shift or phase shift, and D is your vertical shift. Period. And this determines phase shift. Okay. Also for sine, remember that sine at the beginning of its cycle is at 0, goes up to its maximum, back to 0, down to its minimum, back to 0. So the basic graph with the maximum being 1 and the minimum being -1. So that's your plain old y equals sine x graph. All right, same things with cosine. I'm not going to relabel all those. It would be the very same components there, but we're just, it also applies to a cosine graph. But do remember that with cosine, at the beginning of its cycle, it starts at the maximum and then hits its x-intercept, down to its minimum, back to 0, and back to its maximum. So this would be the plain cosine of x graph. So we'll keep those in mind as we're looking at coming up with the equation. So basically what we have to do is fill in the components of the equation. So if we decide if it's a sine or a cosine, we've got to fill in the amplitude. If there's a vertical shift, if not, this will be 0. Is there a phase shift? If not, that will be 0. Is there a period change? If not, that will stay 1. All right, so let's look at the first example here. So as I'm looking at the graph, first thing I'm going to kind of do is identify, do I want to use a sine or a cosine graph to model this? So since this graph at 0 at the beginning of the cycle starts at 0, and then it reaches its maximum, back to 0, its minimum, back to 0, this follows the cosine pattern, or I'm sorry, the sine pattern. So I'm going to use a sine graph for this. All right, so I'm going to look at the amplitude. So amplitude, I do see a stretch there because the sine typically only goes up to 1 without an amplitude change. This graph is going up to 3 and down to -3. So my amplitude on this graph is 3. All right, is there a period change? Well, 0 begins the cycle at 0, ends at 2 pi, so the answer is no, there's no period change. So nothing's going to change on the B, will just be 1. There's no vertical shift because the graph is oscillating around the x-axis. It's 3 above the axis, 3 below the axis. This is kind of the midline. And so really the only change in this graph is going to be the A. So I can do this. This is a pretty simple function. So y equals 3 sine of x. All right, now I do like to, just to double check it, let's just make sure that if I were graphing this function, this is what it would look like. So I'm thinking the sine graph has a period of 2 pi divided by b, and if b is 1, so 2 pi divided by 1 is 2 pi. So the graph would begin at 0 and end at 2 pi. That would be one period of the graph. That's consistent with our equation. Sine, which starts at 0 and then goes to the maximum with the amplitude being 3, it should go up to 3, back to 0, down to -3, and back to 0. And that is consistent with what our graph looks like. So this is the equation that models that graph. All right, let's look at example 2. So just kind of taking a look at the graph here. This graph starts at the minimum, -4, and then crosses the x-axis, and then reaches its peak in the middle of its cycle of +4, crosses the x-axis, and then back down to where it started. So it looks a lot like the cosine graph, except for if we kind of compare and remember the cosine graph, didn't start at the minimum, it started at the maximum. So remember, what causes that reflection is just having a negative in front of the amplitude there. So we'll keep that in mind. So we'll use a cosine graph to model this with it being with a negative, y equals a negative a. Okay, so the amplitude on this graph is 4. Let's look at the period. The period of this graph, it completes the full cycle in 6 radians. So the period is equal to 6. Now, in order to write the equation, remember, I need to know the value of b and the value of c. Well, with the period being 6, remember that 2 pi divided by b equals the period, which is 6. So if I could solve that, I'll know what b is. And so I'm going to multiply by b. And so 2 pi equals 6b. And then I would divide by 6. And so b is going to equal, and for me to reduce that, pi divided by 3. So there is my b. I know my amplitude. Now, there's been no shift because the cycle begins at 0, and so the phase shift there is a phase shift, so c would be 0, and there's been no vertical shift. The graph is oscillating around the x-axis, so d would be 0 as well. So as I write the equation, remember we're using a cosine function. Remember we have to use a negative because it is a reflection over the x-axis. And so -4 cosine bx, so b is pi thirds, plus 0, so I can just stop there since c is 0. And so this would be the equation that this graph models. If you want to just, again, a good idea to check it, 2 pi divided by pi thirds would be 2 pi times 3 over pi. The pi would cancel, you get 6 for the period. That matches the graph. Amplitude being 4, with the negative we know instead of starting at the maximum for cosine, start at the minimum, cross 0, reach the maximum in the middle of the cycle, 0, and then end the cycle at the same place it started at -4. So this equation matches the graph, so that equation is the equation for that graph. All right, example 3. So as I'm looking at this graph, because it starts at 0, looks more like the sine function than it does the cosine. The only difference is sine function starts at 0, goes to the maximum first, back to 0, to the minimum, and back to 0. So because it's going down first instead of up, like the previous problem, it's a reflection. We're going to have to use the negative. So we have to remember that when we get ready to write our equation, that we have the negative for the reflection. Okay, so let's start with the amplitude on this one. Amplitude is 5. So A is 5. So, all right, the period. So it completes the full cycle between 0 and 8 pi. So we have a period of 8 pi. All right, so 2 pi divided by b is equal to the period. The period is 8 pi. So I'll solve to find out what b is. So I'm going to multiply by b. 2 pi equals 8 pi times b. Dividing by 8 pi to solve for b gives me 1 over 4 for b. So there's my v. There's my a. All right, because again, the cycle starts at 0. There has been no phase shift, so c is 0, and there's been no vertical shift. It's still, the graph is oscillating around the x-axis, so d is 0. All right, so our equation for this one, y equals, remember the negative because it's going down first, so negative sine. Oh, and I forgot my amplitude. I need to stick my 5 in there, so let me do this. 5, -5. Bx, so 1/4 x, there's no c, so y equals -5 times the sine of 1/4 x. So let's just double check that. 2 pi divided by 1/4, the same thing as 2 pi times 4, that's 8 pi. That matches our period. A sine function starts at 0. Typically it goes up first, but because of the negative, we go down first. The amplitude is negative, so it should range between -5 and +5, and it does. And so this equation does match this graph. Okay, this is example 4. All right, so in this function, I'm looking at, it looks like it starts, if we start this as the beginning of a cycle and goes up to its maximum, back to the beginning, down to its minimum, and back to where it started. Okay, so that resembles a sine function. So I would probably use a sine function to graph this. Okay, so I'll go ahead and set that up. All right, so the amplitude, so I can see how the graph is not oscillating above and below the x-axis. It actually looks like, if you look at the highest point 4 to the lowest point -2, that's the distance of 6. So the middle of that would be at 1, middle of that distance. So you can see that the graph it's as though this is kind of our imaginary x-axis, which has now been shifted up 1. So because of the being shifted up 1, that represents a vertical shift of 1, and so the vertical shift in my equation is the d value. So I'm going to go ahead and make a note that d is 1. All right, and so from here, the amplitude from 1 to 4, it's like the amplitude is 3, so I'll go ahead and fill that in. I'll go ahead and put my +1 on the end here for my vertical shift. That's my d. All right, so my bx plus c is left to fill in. So let's look at the period. So the period, make a note here, my amplitude was 3. So my period on this graph is from, well, it looks like it goes from -1/4 or so to, basically if I shifted this over to 0, that would shift over to 4. So you can kind of see that the period is 4. All right, well, again, 2 pi divided by b equals the period of 4. If I solve that for b, multiply by b, I get 4b equals 2 pi, and then divide. All right, so b equals pi halves. I went ahead and reduce 2 pi fourths to pi halves. So there's my b. All right, and we do see a shift here. So the shift, remember the phase shift is -c divided by b. And I do note the shift is negative. It's shifted back -1/4. So each one of these is a fourth, 2/4, 3/4, 4/4. So it shifted back one little notch there, so -1/4. And I do also know that b is pi halves, so -c over, I'll go ahead and fill in b. All right, and then if I solve that, I'll just multiply both sides by -pi halves, and that would have c is going to be equal to pi eighths. Okay, now once I know a, b, c, d, I can fill in my equation. So a sine of bx plus c, so pi halves is b plus c plus, and then d. So now this is my equation, and that one had a lot going on in it. Everything basically that could be changed, other than maybe a reflection, was changed. All right, so let's just glance at this and make sure that this represents this equation. That's a model for it. So solving for my shift first, let's see, I would have -c over b, -pi eighths over pi halves, which would be -1/4. That represents a shift. It's good there. The period would be 2 pi divided by pi halves, which would end up being 4, which from the period we saw that is 4. It should, with the upshift of 1, it's going to oscillate above and below the line y equals 1. And the amplitude, so it should go 3 up to 3 above the new x-axis, back to the x-axis, the imaginary x-axis, I should say, down to the minimum and back up, with the amplitude being 3. So this model matches the graph, and we're good. All right, example 5. All right, so in looking at this, again, we're trying to write the equation that models this graph. So again, it comes down to finding in my function, my y, whether it's a sine or cosine. I'll put sine or cosine of bx plus c, and then your vertical shift. Okay, so let's look at, I do notice there's been a vertical shift because the x-axis is not oscillating around the x-axis. It's been shifted up. So if you're unsure about exactly where the middle of that is, so from -3 up to 7, that's 10. Half of 10 is 5. So 7, so it would be at 2. Be right in the middle. All right, so that represents a shift up of 2. So shifting up 2, so that means my d is going to be 2. All right, amplitude, so from 2 up to 7, that's 5. So my amplitude is going to be 5. All right. Now, as far as is this a sine or cosine function? So if we let this be the beginning of the cycle and let the cycle start here and end here, and we're going to graph that. It starts at basically 0, even though it's been shifted up 2. But it's that model is a sine wave. But notice that sine typically goes to the maximum first and then to the minimum. This one goes down first, so we would take care of that with the negative to make the reflection. Okay, so now I just need to finish my B and C, and that will be everything I need to be able to graph this, but I'll circle sine, which is the one we're going to use to model this. Okay, so the period of the graph goes from 0 to 2 pi thirds. Okay, so the period is 2 pi thirds. All right, so what then would B be? So 2 pi divided by what equals 2 pi thirds? Okay, well, obviously B has to be 3. And then I just need C, so my phase shift. Well, there has been no phase shift. There's been no shift, so C, I really don't need to solve that. It would be 0, or you could, C divided by 3 equals 0 and solve it, and you end up with C equals 0. So C is 0, B is 3, and so now let me come over here and write the equation. So y equals -5 sine of 3x, I don't really need to put plus 0, plus 2. So make sure you close the parentheses there if you're going to put parentheses around it, so that you're taking the sine of 3x and then adding 2 and not taking the sine of 3x plus 2. All right, so that should be the equation. I would always like to double check it. So does it look like it matches the graph? Well, we got the vertical shift up of 2, so it's kind of like here's our new x-axis. Yeah, the amplitude is 5. That works. 2 pi divided by b, 2 pi divided by 3 with no shift means the graph should start at 0 and end at 2 pi thirds. Perfect. And then, of course, it's going to go down because the negative is going to go down to the minimum first, back to 0, then back to the maximum, back to 0. When I say 0, I mean 0 is that this is the x-axis. So it works, and it models the equation. All right, last example. All right, so in this graph, example 6, I'm looking at the beginning of the cycle at 0. Completing, that would be a sine wave, goes up to its maximum, back to 0, down to its minimum, back to 0. So it's completing one cycle between 0 and pi. So I see the period is pi. Let me go ahead and find B since I've got the period. So 2 pi divided by what equals pi? All right, so if you realize B has to be 2. Again, there's been no shift. It's starting at 0, so that makes it nice and easy. C will be 0. There's been no vertical shift because if you notice the graph is going up to 3 and down to -3, so this is the midline there. So D 0 meaning no vertical shift. And the amplitude, yeah, the amplitude is changed. So the amplitude is 3. So A is 3. And so then I can write the equation of using sine. So y equals A 3 sine bx, so 2x, and then a plus 0. So All right, let's double check it. So 2 pi divided by b. 2 pi divided by 2 is pi, so period should be 0 to pi, yes. Amplitude's 3, it's a sine graph, so it should go start at 0, go to 3, back to 0, down to -3, back to 0. It's good.